This is the third example for the first and second derivatives, increasing, decreasing, concave up and concave down, off of the review sheet. So for problem number 3, we're given a function f of x is equal to x plus 2 cosine x. So just like all the others, start out by taking derivatives, and we come out with f prime is equal to 1 plus 2 times negative sine x, which is the same as 1 minus 2 sine x. Alright, and so now we take our f double prime is going to be equal to 2 minus 2 times negative cosine, nope, sine is just cosine x. You always got to pay attention to what you're doing. So that simplifies to negative 2 cosine x. Alright, so our next step is going to be setting these equal to 0. So setting our f prime equal to 0, should have negative 1, and we will divide by negative 2. And so we get sine of x is equal to 1/2. Okay, so keep that in mind, and I'll pull that up in just a minute. I'm going to do a handy little chart from way back in trig, so pre-cal, so it'll actually help us out here in just a minute. And then setting our f double prime, which was negative 2 cosine x, setting that equal to 0, divide by negative 2, so we get cosine of x is equal to 0. So this is the handy little chart that I was talking about. So sine of 0 is 0, sine of pi over 6 is 1 over 2, sine of pi over 4 is the square root of 2 over 2, and sine of pi over 3 is the square root of 3 over 2, and the sine of pi over 2 is 1. And so basically for cosine, you just reverse the order of your numbers. So we're going to have 1 square root of 3 over 2, square root of 2 over 2, and 1/2, and then 0. Okay, so if you remember, for our first derivative, we had sine of x is equal to 1/2, and so that is right here at pi over 6. And also we had a cosine 0 for our f double prime, which happens at pi over 2. Okay, so now we're going to expand on that for just a moment. Okay, so when we're dealing with sines and cosines, basically any of the trig functions, we normally deal with radians, and these are just the quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in quadrant 1, both sine and cosine are positive. In quadrant 2, sine is positive and cosine is negative. Quadrant 3, both are negative. And in quadrant 4, sine is negative and cosine is positive. Okay, so we had sine of x was equal to 1/2 as the 0 for our first derivative, and we said that happened whenever x was pi over 6. Well, also, if you take pi over 6, which would be going roughly there, if you look at over here at pi, sine is going to be 0. But if you extend that, a pi over 6 amount, basically you're going to be subtracting pi over 6 from pi, and you'll get 5 pi over 6. So sine is actually equal, sine of 1/2 is actually equal to pi over 6, 5 pi over 6, because sine is a periodic function. And also, for cosine, cosine x was equal to 0, and cosine was 0 at pi over 2, which would be right here up near the top. Well, at 3 pi over 2, here cosine is going from positive to negative, which means that it has to hit 0 at pi over 2. And as you can see down in quadrants 3 and 4, cosine is going from negative to positive, so it's going to hit 0 again at 3 pi over 2. Okay, so pi over 6 and 5 pi over 6, along with pi over 2 and 3 pi over 2, are going to be our critical values. Okay, so I've made the number line, and I've put our f prime and f double prime over here, and I actually took the derivatives right here, and I put another little handy tidbit of information right here. Okay, so on our number line, our critical values were pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. So we need to know what's happening, to the left and right of those. So I picked the numbers to plug into our derivatives down here on the bottom of 0, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And I picked those just because, sine of pi over 4 and cosine of pi over 4, is both equal to the square root of 2 over 2. And as far as the, 3 pi over 4, that's going to be in quadrant 2, where sine is still going to be positive, and, cosine is going to be negative. So we just need to pay attention to that. That we plug those values in for our x's, and when we do that, sine of 0, which is our f prime, sine of 0 is 0, 2 times 0 is 0, 1 minus 0 is 1, so that's going to be positive. And so then we just plug in pi over 4, which is the square root of 2 over 2. 2 times the square root of 2 over 2, the 2's are going to cancel, so we're going to be 1 minus the square root of 2. Well, the square root of 2 is larger than 1, so we're going to have negative. And 3 pi over 4, it's going to be a positive square root of 2 over 2, same thing, it's going to be negative. At 5 pi over 4, we're going to be in quadrant 3, and sine is going to be negative there. So we're going to have a 2 times the square root of 2 over 2. 2's cancel. So we're going to have 1 minus a negative square root of 2. So that's going to make that a positive. And the same thing for 7 pi over 4. we're going to be in quadrant 4, sine is going to be negative, so we're going to have a positive. Okay, so now just go through and plug everything in for the x on the f double prime. So at 0, cosine is going to be 1. So we're going to have negative 2 times 1. So it's going to be negative pi over 4. The 2 is going to cancel. We're still going to have a negative. 3 pi over 4. We're going to be in quadrant 2. Cosine's negative. We're going to have a negative times a negative, so we're going to have positive. 5 pi over 4. Cosine is still negative. So negative times negative is positive. And at 7 pi over 4, cosine is going to be in quadrant 4, which is going to give us a positive square root of 2 over 2. And positive times the negative is going to give us a negative. So here we can see we are increasing down, or concave down. And we're going to have a decrease down, decreasing up, increasing up, and increasing down. I know this video was a little long, but hopefully the explanation helped make sense of things a little bit for you.